Hi, welcome back. We are with the second question discussion. As you can see in the question, the second question is from chemical calculation. Under chemical calculation, we have a very important part. It's about the redox reaction. So this question is from redox reaction, mainly about the balance in redox reactions. There are two methods we can balance redox reaction. That's by using oxidation state method or by using half reaction method. In this case, the question can be done by balancing the reaction using oxidation state method or half reaction method. But here I will explain how to do this one using half reaction method. So what about the question? Question is about oxidation of ethanol, CH3CHO, to acetic acid. Ethanol, acetaldehyde, ethanol to acetic acid or ethanoic acid by acidified potassium permanganate. Using acidified potassium permanganate. You know what happened in the case of acidic medium, permanganate goes to Mn2 plus. So then you are asked to find out the total number of electrons exchanged during this oxidation reduction reaction. Let's see how to find it out. First of all, we should construct the oxidation half reaction and the reduction half reaction. In this particular case, I will write the equation like this. I take all the carbon atoms together, hydrogen atoms together, and oxygen atom together. Here also all the carbon atoms together, hydrogen together, and oxygen together. Because it will be it will be easy for me. It's convenient for me. So that's why I write it here. Then I balance carbon first, already balanced 2, 2. Then I balance oxygen, 2 and 1. Then how to balance oxygen? When we balance oxygen, we add water. 1 water means 1 oxygen. Here we need 1 more oxygen. Then 1 more water should be added. Now oxygen is balanced. Thereafter, we go to balance hydrogen atoms. When we balance hydrogen atom, what we use? H plus ions. We add H plus ions. In this side, we have 2 plus 4, then it's 6 hydrogen. This side only 2, 4. Then there should be 2 more hydrogen. So we add like 2H plus. Then hydrogen also balanced. But finally, we should go to the charges. How to balance the charges of this one? In this particular case, actually, by considering the oxidation number change, you can balance the charges, or by considering the overall charge of reactant side and product side, you can balance this one. Either way, it is then possible. But in this particular case, I go to the overall charge. That will be easy for me. 0 and 0. Then this side, the overall charge is 0. 0 and plus 1 into 2 plus 2. 0 plus 2, then this side, the overall charge is plus 2. Then what do we do? How to balance the charges here? Actually, in this particular case, remember, to balance the charges, what we add electrons. Adding electron means adding negative charge, minus 1. So in this particular case, then you can take plus 2 to 0 or 0 to plus 2. Both ways it's balanced then. You can take plus 2 to 0 or 0 to plus 2. Either way, it's correct then. In that particular case, I think it will be easy to take plus 2 to 0, because only thing you have to do here, adding minus 2 for this one. Then adding minus 2 means simply adding 2 electrons to this side. Electron means minus 1. Then minus 2 means 2 electrons should be added to this. It's okay. If you want to convert 0 to plus 2, it can be done. But how? Then you have to add plus 2 here. Plus 2 means not adding 2 electron. If you add 2 electron, it's minus 2. How can we introduce plus 2? It should be minus 2 electrons. In this particular case, not adding but subtracting 2 electron from this. Minus 2 electron, then electron minus 1, 2 electron minus 2, minus 2 electron mean minus 2 mean plus 2. Then it is balanced. But in this case, adding electron to this side will be easy. So keep that in your mind. So if you get, if it is difficult to decide this one, that's the logic behind this. But if it is difficult to decide these things, you can memorize it in this manner. If you get positive and neutral, we add electron to positive side. If you get neutral and negative, we add electron to neutral side. If you get positive and negative, we add electron to positive side. If you get positive, positive, we add electron to more positive side. If it is negative, negative, we add electron to less negative side, not to the more negative side. We add electron to less negative side. So these are the possibilities we can have in this type of balancing equations. So you can simply memorize it, but you should know the logic. But if it is difficult, then this is the way we construct it. Okay, then we get 0 and plus 2, positive 0, positive neutral, we add electron to positive. Next question, how many electrons are added? That's the question. So it's okay. Get the difference here. 0 to 2, it's 2 different. Therefore, you add 2 electrons. 2 electrons to what? Positive side, this side. Positive side, we add 2 electrons. Now you see plus 2 minus 2, it's cancelled 0. This side 0, charge is balanced. Right. Let's move to this one. Here, actually, to get the answer for this total number of electrons exchange, to get the answer, we don't need balanced chemical equation. I mean, we don't need the molecular equation, full equation. Simply the full ionic equation is enough for this one. Full ionic equation enough. Therefore, I don't take KMnO4 whole compound, but I take MnO4 minus. MnO4 minus. This is very famous one. You have maybe you have done several times here, balancing this one, this half reaction, constructing this half reaction. Maybe it's a famous one. In theory classes, we have done it. Mn already balanced, then oxygen 4. To balance oxygen, what we need water. 4 oxygen mean 4 water. Hydrogen not balanced, 8. To add hydrogen, what we use H plus, 8H plus. That's the atom. I mean, atoms are balanced now. Next, we have to go to the charges here. I take the overall charge part, you know, plus 1 into 8 plus 8 minus 7. It's plus 7. This side plus 7. Here plus 2, 0. Plus 2, 0. What do we get? Overall plus 2. Then you get positive, positive. If you get positive, positive, we add electron to more positive side. So which one is more positive side? This one, plus 7. How many electrons should be added? The difference. It should be 5 electrons. Then look at this. We got reduction half reaction here, oxidation half reaction, lose in electron oxidation. Then if electrons are in product side, it's lose in electron oxidation. If electrons are in reactant side, gain in electron reduction. Then we have to balance it. So we have to construct the full ionic equation. So when you take the full ionic equation, electrons cannot be there. Electron should be cancelled out. When to cancel electron, both sides there should be same number of electrons. So 2 electron, 5 electron. Then best thing is to multiply this by 5, this by 2. You know, then 10 electron, 10 electron cancelled out. Then I take the full ionic equation here like this. You know, 5 water and 8 water. Then 5 water cancel mean 3 water should be there. I'll write it later. This is 5C2H4O plus. This is C2. This should be 2 into 5, 10 electron. I write it here because that's our question. To show it, I take it. 2 into 8, 16H plus. 5 into 2, 10H plus. 10, 16. What's remaining? 6H plus remains. Plus, this is multiplied by 2, 2 permanganate. Right. Goes to, this is by 5, 5C2, 5C2H4O2 plus. This was already cancelled, 5 to 10, and here it's cancelled, no more H plus. This is by 2, then it should be 2Mn2 plus, plus. This is 8 water, but here 5 water cancelled, then 8 minus 5, it's 3 water remaining. This is the full ionic equation, but here you have electron, 5 into 2, 10 electrons available here. Look at this. Your question is total number of electrons exchange. That is what you can see here. 10 electrons accepted, 10 electrons are removed. So therefore, 10 electrons exchange during this oxidation and reduction reaction. So because of that, your answer should be 10 electrons. So where do we find that answer? 10 electron. That is in fourth answer. So in this particular case, the answer should be fourth answer. Right. I hope you understood this. We will meet again with another question. See you then.